Yeah, hello guys. So today we will talk about the OpenStack Cloud, right? So, what is OpenStack? What is OpenStack Cloud? What is cloud computing? What are the features of the cloud computing? And what is the need of the cloud computing, right? So, so these are all the today's agenda, which will talk about. Okay. Yeah. So this is our agenda, right? So before talking about the cloud computing, and OpenStack, we will first of all we will try to understand the traditional data approach, right? So cloud computing existing from last 4 to 5 years, but before that there was no concept of the cloud computing, right? So in that time, if we talk about 15 or 20 years ago, so how the applications are deployed, how the applications are run in the data centers, right? So first of all, we will try to understand about the traditional data approach, then we'll go to the virtualization, then the virtualization comes, and then we will try to understand about the cloud computing. Okay. Yeah. So this is physical data center, right? So if we talk about our physical data centers, so at a high level, what are the component of the data center? There is a network layer. There is a network layer, which is this. This is suppose this is your firewall. This is your switches, router and switches. There is a storage layer, right? So this is your storage part, and there is a compute layer. So this is the servers. So in a data center, at a high level, in a data center, what are the three fundamental pillars? Network, storage, and compute. So networks, firewall, routers, switches, right? And storage layer, your storage devices, where your data center's data is stored, right? It can be a SAN, storage area network, it can be a NAS, or it can be object, right? Where your actual data is stored. And the third one is the compute. Compute, the servers on which your applications are deployed and run. So 15 or 20 years ago, uh, in data centers, so what was the traditional data center approach? Hardware based provisioning. One customer, one hardware model. What it means? It means, let's suppose you are an organization which provides the services in the form of data center, right? So a customer if customer wants to deploy his or her services in your data center, so what you will do, you will configure the network layer, you will configure the storage layer, and you will configure the compute layer. I mean, you will configure the storage on the compute layer, and on the server side you will install your application. It doesn't matter what kind of application it is. It can be a Java application, it can be a Python, it can be any kind of language, any kind of application you will deploy on the server, right? So that means in a traditional data center, so what is the drawback? One customer, one hardware model. So suppose you have n number of applications which you want to run in production. So for n number of applications, you require n number of physical servers, which will be connected to the network layer and the storage layer, right? So for scaling up more users, more hardware required. Yes. So if you want to scale up your application, you require more hardware, you require more data center resources. So TCO and setup cost are high. That means your total cost of operation is very high in that case, right? And your setup cost is already hard, because in that case you have required a lot of manpower, right? You require a lot of data center resources, compute, network, and storage layer. So, and the total provisioning time is also high. That, because if you want to deploy a service in the production, so it will be a time consuming process, because everything was manual. For everything and every configuration, it takes a lot of time, right? So this is the traditional data center approach, where the applications are deployed and run, and these are the drawbacks of the traditional data center. So after that, what comes? Now the data center becomes virtual. How the data center becomes virtual? Virtualization platform comes. So what virtualization does, right? Virtualization actually virtualize your compute layer, right? So these are your physical servers, and these are your virtual machines. So means the virtualize, yeah, abstract the physical layer of the servers, right? But your network part, firewall, switches, routers, and storage layer is 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 still taken care by the manual steps, right? So if we talk about the virtualization, so what are the virtualization technologies? uh, VMware, KVM, Hyper-V, right? So in that case, so what VMware does, because I think most of the folks has worked on the VMware or KVM. So what VMware or KVM does, you install a virtualization software, be it is a VMware or a KVM or a Hyper-V, on a physical machine, physical server, and on top of that, you create more virtual machines, where you actually deploy or run your application, right? So that means the virtualization virtualize your compute layer. Hypervisor, abstraction for the hardware and software. Abstraction for hardware and software means your compute layer is virtualized now. Abstraction allows for the pooling of storage, network, and compute resources both on hardware and manpower that can be dynamically allocated on demand. A degree of automation of physical resource. Yes, in virtualization, we have done a degree of automation of physical resources, right? Because in traditional data approach, we have a one-to-one mapping. If we want to run a application in the production, we have to deploy it on a physical server, right? But in virtualization, on a physical server, we have installed or we have run a hypervisor, VMware or KVM Hyper-V. On top of that, we are running the virtual machine. So we have automated automation. We have done the automation of the physical resources. Virtual instances running concurrently, sharing resources, provisioning time reduced, right? So what in virtualization, what we have done now, uh, now we are in virtualization, we are able to create the virtual machine on a single click, right? If we want to create a new virtual machine, so it is just the steps of a few click, and a virtual machine is created where we actually deploy our application. So total provisioning time reduced, right? And the total cost of operation is also reduced. So as compared to traditional data approach in virtualization, less number of manpower required, right? And the total provisioning time is also reduced. Now, after the virtualization, what comes? So this is the virtualization Gotchas. Doesn't provide flexibility in terms of growing customer scenarios, right? Customer infrastructure has a tight integration with the DC infrastructure. With Because in virtualization, what we have does, we have only virtualized the compute layer, right? The network layer and the storage layer is still in the man. All the things are managed by the manual steps, right? So no automation with respect to the network and the storage. Though change times are less, but they are still high enough as compared to traditional data approach. Service models are very tightly integrated with vendor architecture, no vendor neutrality, right? So, uh, in that it means in your data center you are tightly integrated with the vendor. Let's suppose if you if in your data center if you are using the VMware enterprise software for running your application, so you are very tightly integrated with the VMware, right? So if you want to migrate your application on a Hyper-V or KVM, so it takes a lot of effort. The- right? So in that case, so there is no vendor neutrality. Thus, no extra benefits from traditional model except better utilization of resources. So if we compare the virtualization from the traditional model, then in virtualization we what we have achieved, we are we have started to utilize our compute resources more, because in traditional data center we are running only one application in one physical server. In virtualization we have started to run multiple virtual machines or multiple application on the physical servers, right? So these are the virtualization gochas. Now after the virtualization, what comes? The cloud comes, cloud computing comes. So what is cloud computing? So delivery of computing resources, data and storage resources as a service to end users over a network. So at a very high level, what cloud computing does actually? Cloud computing virtualize your network, storage, and the compute layer at the same time, right? Cloud computing provides multi-tenancy, orchestration, automatic provisioning, flexible service models, etc. in terms of infrastructure, storage, and platforms. So let's take the example of the AWS. So what is AWS? It is a cloud computing solution or any public cloud, AWS, GCP, Azure. These are the cloud computing solutions, right? So and every cloud provides three kind of fundamental services. It doesn't matter it is a public cloud or it is a private cloud. What are these fundamental services? IaaS, PaaS, and SaaS. What it means? Infrastructure as a service, platform as a service, and software as a service. So If we talk, if we let's okay, let's take the example of the AWS. So what is the service of AWS which provides infrastructure as a service? Anybody can tell me? Anyone? Okay, EC2. Everybody has worked on the AWS, right? So EC2. So what you does in EC2? You provision a EC2 instance on AWS. That means you are so so that means AWS providing you infrastructure as a service in the form of EC2, right? Now the next part is the platform as a service. What is the platform as a service? If we talk about talk about AWS, what is the platform as a service? RDS, EKS, right? RDS is a database service. So database, it is a platform. EKS, it's a platform of Kubernetes, which AWS provide as a platform as a service. Okay, and the third one is the software as a service. So what is the software as a service? Where so software as a service is a kind of service where all the component of the software is handled by the provider, like Gmail. Gmail is a service of Google, so it's a software as a service. Google Drive, right? So this is a software as a service. So every cloud, it doesn't matter it is a private or public. So every cloud provides these fundamental services: IaaS, PaaS, and SaaS. So these are the features of every cloud: self-provisioning, orchestration, pay-as-use, and elasticity. So self-provisioning, what it means? Self-provisioning. So how cloud provides self-provisioning? Okay, let's take the example of the AWS. So in AWS, you have heard a term that is called the auto scaling. So what happened in auto scaling? It is automatically scale the EC2 instances, right? You don't need to do anything. You just configure the parameters. Everything is taken care by the cloud, AWS, right? Orchestration is the fundamental features of a cloud, right? You, I mean, you just configure the parameter and cloud automatically orchestrate automatically, pay as you use. So this is the third feature of cloud. So as you will grow, right, you will pay more. If your users on the cloud side is less, you will pay nothing. But as you will grow, your you will pay more. And the fourth is the elasticity. This is the four fundamental features of cloud. Elasticity means it will automatically scale your application as the demand will increase, right? You will just configure the parameter. Let's suppose you are running your application on the EC2 instances, right? And you have configured the auto scaling. As the application, as the load on the application will increase, it will automatically scale out your application. So that is the elasticity. Okay. Now The next part is how do you do that, right? So because AWS, Azure, or GCP, these are the public cloud, right? So, but as a cloud provider, if you want to implement your own cloud and you want to provide the three fundamental cloud services to your customers, so how you will implement your own cloud in your data center, right? So for that, what you have required, single controller controlling your compute, network, and storage and security devices, right? So that means you required a controller which actually which actually control your compute, network, and storage devices. Single dashboard, only the single dashboard for the end user. Let's suppose in AWS, when you will log in on the AWS, you will only get a single dashboard. Okay, all components adhere to that single controller's API for management and operation. That means you have a single dashboard only, and you have such kind of mechanism, such kind of system where your backend system talk to your dashboard with the APIs, right? User management and service delivery is also handled by the cloud controller. So at a very high level, if you want to deploy or if you want to create your own cloud, you need a controller with a single dashboard which actually talk which will actually talk to the different component, your network layer, compute layer, and storage layer. For and for the user management and service delivery, there should be a some mechanism by which the users can log in and log out and use the cloud services. The solution is OpenStack, right? So OpenStack is a cloud solution which provides you the three fundamental services by which you can give three fundamental services to your customer, right? And so this is a very high level diagram. This is your application, this is your compute layer, networking layer, and storage layer. This is your standard hardware. Okay, the standard hardware means this is your uh, the physical servers in your data centers, and these servers can be Cisco Blade server, rack servers, anything. On top of that, you are running your OpenStack solution. Okay, and this is your OpenStack dashboard, and every interaction with the backend services is done on the API layer. Okay, so this is a very high level diagram. Now go a little bit deep down. So in OpenStack, so these are the core component of OpenStack. What are the core component? Horizon, Neutron, Cinder, Nova, Glance, Swift, Celometer, Probe, and Keystone. Right. So these are the fundamental component of OpenStack. And what is the functionality of each component? So in this session we will talk about the Nova only, but I will give you a brief introduction about other component as well. Right? Horizon. Horizon is what? It is a dashboard service of OpenStack. Means when you will deploy the OpenStack in your data center, the first page you will see, this is your horizon. Right? Neutron. Neutron is the component of OpenStack which provides the networking service. It is just like the VPC in AWS. Right? Cinder. Cinder is the block storage service of OpenStack. It is just like the EBS in AWS. Nova. Nova is the component which actually provides the compute service of OpenStack. It is just like the EC2 service of AWS. Glance. Glance is the component of OpenStack which stores the cloud images. It is just like the AMI of AWS. Swift. It is the object storage service. Object storage service of OpenStack. And what is the object service of AWS? S3. Okay. Keystone. Keystone is the identity provider service of OpenStack. And what is the identity provider of AWS? IAM and role policies. Right? So for building your private cloud, you would need the OpenStack, and for building the OpenStack, you require these kind of services. These are the fundamental services. Okay. Now in this session, we will talk about the Nova. So this is the Nova service. So as I have told you, Nova is the service which provides the compute service. Compute service means it is just like the EC2 service of AWS. So what you does in EC2? You create the EC2 instances. In the same way, in OpenStack, if you want to create the virtual machine, you require the Nova service. Right? Now the intern. Now there are different component of the Nova service itself. Nova API, Nova scheduler, Nova conductor, and Nova database. Right? So let's talk about the each about every service. So Nova API. So uh, so let's suppose you want to create a virtual machine in OpenStack. So first of all, you will log in on the Horizon, right? So after successful login on the Horizon, Horizon is what? It is a dashboard service of OpenStack, right? On the Horizon, you will get a page where you want to create your virtual machine, right? Just like the AWS. So, so this is user. User means this is the end user. This is so when any user want to create a virtual machine in OpenStack, the request comes to the Nova API, right? So it is a REST API service. It is nothing just API service. Guys, I give you the demo of this OpenStack, but actually the system from where I am giving this session. So on that laptop, my OpenStack setup is not working. It is working on the other laptop, right? So if anybody wants to more about the OpenStack, then I will give you the demo later. Okay. So right now I will give the theoretical knowledge actually how all the things will work in OpenStack. Okay. So so when any user wants to create a virtual machine Nova in OpenStack, the request comes to the Nova API, right? So in OpenStack, when you install the OpenStack solution on your servers, you required a message broker. So in OpenStack, the message broker which is used, that is called the RabbitMQ, right? So this is the RabbitMQ message broker. So RabbitMQ message broker is used for the RPC call. RPC call means when a when all the internal component of a service, component of a service means, let's suppose Nova. So what are the internal component? API, scheduler, conductor, and database. If these services want to talk to each other, they talk to each other through the RabbitMQ broker, through the RPC call. Okay. And when any intra service like Nova, when Nova wants to talk to Glance, or when Nova wants to talk to Neutron, those communication happen at the REST API. Okay. So that is the main difference. When the intern component want to talk to each other, they communicate at the message broker, and across the application, communication had happened at the REST API. Okay. And now the second component is the Nova scheduler. So what Nova scheduler does, it actually filter out the compute resources. I mean, where your virtual machines will be created. Let's suppose uh, you have n number of physical servers, and you want to create a virtual machine. So in which physical server the virtual machine will be created, right? So that decision is taken care by the Nova scheduler. Okay. And Nova Conductor is the only service which talks to the Nova database, right? So for every component, Nova, Glance, Neutron, or any component of OpenStack, every service has their own database where it stores the uh, state information of that service, right? So let's suppose Nova, yeah, uh, let's suppose Nova wants to, and there is one more service that is called the Nova Compute. So Nova Compute is the service which actually create the virtual machine on the physical server, or we can say Nova Compute is the service which actually talks to the underlying hypervisor, be it is a VMware, KVM, or Hyper-V, and create the virtual machine. Okay. So when you want, so what is the creation of the what is the flow of creating a virtual machine in OpenStack? So request comes to the Nova API via the REST API call. Now that call is goes to the Nova scheduler via the RabbitMQ, by the message broker. Nova scheduler what does, it actually filter out the compute resources where the virtual machine will be created, and that information is stored on the Nova database by the Nova conductor, right? And when the request goes to the Nova compute service, Nova compute service actually talks to the uh, underlying hypervisor, be it VMware or uh, Hyper-V or KVM and create the virtual machine. So that means Nova is the abstraction layer. Nova is the abstraction layer where which is taking the decision and creating the virtual machine on the underlying hypervisor, right? But in case of virtualization, who is the person who is taking all those decisions? You are the person who actually taking all the decision, right? So if we okay, so if we talk about the VMware, so in VMware, what happened? You have a cluster of the ESXi host, right? And when you want to create a virtual machine on the ESXi host, you take the decision on which ESXi host the virtual machine will be created, right? You are the person who actually decide in which network that machine will be created. You are the person who decide how much the storage of that virtual machine would be. What is the compute capacity of that virtual machine? What is the RAM, CPU? So you are the person who actually decide the resources of a virtual machine, right? So that means everything is manual. You have to click, you have to log in on the VMware console, you have to follow all the steps. But in cloud computing, right? In cloud computing, all the decision is taken care by the compute layer. And in OpenStack, it is the Nova. In AWS, it is the EC2. Okay. Okay. Any question? Thank you so much. Any question on that?
No, Vikas.
And if anybody wants a live demo of OpenStack, he or she can connect with me, and I can give you the live demo. Actually, how the things work in OpenStack. Okay.
Okay.
Yeah, so thank you so much to all of you.
Thank you. Bye.
Thank you.